Welcome back, level 3s to 3.4 atomic structure and bonding. This is lesson 9 on shapes, part B. Okay, so what we're up to now is the template for shapes, because we know that all of these shapes question, it's basically a parroted answer which you can prepare every single time. And so if you know this general template here, you'll get full marks. If you forget one aspect, it drops you down to a merit, and forget two and you're down to an achieved. Okay, so let's say we're talking about trigonal bipyramid here, you know, one above, one below, three in the middle. So whatever the shape is has 5 electron density regions around the central atom, and you should specify what that is. Okay, these repel each other as far as possible, creating a parent geometry of trigonal bipyramid. Okay, in this case there are 5 bonding and 0 non-bonding pairs of electrons, so this also creates a trigonal bipyramid shape. So hopefully that makes sense. It's exactly the same to last year. Nothing's changed. So if you will have all seen this last year, but this is the template I highly recommend using, because if you don't, you tend to miss out a point. However, you know, if you've got the right info, you've got the right info. So what we're going to do here in part B is we are going to draw Lewis structures and 3-dimensional shapes for some of these, and we're going to justify them. Now in this process, I'm actually just going to do 3 and 4, because you do 1 and 2 a lot. They're quite common examples. So we're going to start with ClF3. So if you add up the valence electrons, so these are all in group 17. Okay, so 4 times 7 gives you 28 electrons in total, and chlorine will be the central atom. So, and there's 3 fluorine. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, because any extras we put around the central atom. So what you can see here is we have got 1, 2, 3, 4, 5 electron density regions. Now, those electron density regions are all going to, on the central Cl atom, are going to repel each other as far as possible, creating a parent geometry of trigonal bipyramid. So trigonal bipyramid. Now you can see here there are 3 bonding and 2 non-bonding. So this means that this shape, so if this is trigonal bipyramid, okay, with all of them bonding, you've got 3 bonding and 2 non-bonding. So let's take off the 2 non-bonding, okay, and you end up with this shape here, which is known as T-shaped. Now T-shaped is in fact a planar shape. So you're like, phew, that's nice and easy. So you do 1 up, 1 to the side, and 1 down. If you want to put the lone pairs on the central atom, you actually can, and you won't get marked down. I often do, to be honest, but you can't put the electrons on the fluorines. Okay, so you can do that if you want, but you don't need to. So the bond angle here, because there's we don't do between the lone pairs, we just do between the bonded. So your lone pair here, this angle here between the axial and equatorial, which you can see me doing, would be 90 degrees, and that's all you can do for this one. So yeah, so that's your first one there, and the shape is therefore T-shaped. So now I'm going to verbally go through how you would justify this shape, and I've actually typed up the answer on the next slide, so you can have a look at that in detail should you need to. So we start by saying that there are 5 electron density regions around the central Cl atom. These all repel as far as possible to create the parent geometry of trigonal bipyramid. There are 3 bonding and 2 non-bonding pairs of electrons, and therefore the shape is T-shaped. Hopefully that makes sense. So now we're going to do this one. So we've got 5, this has got 5 valence electrons. Fluorine's got 7 times 5, so that gives us a total of 40 electrons. Okay, so we're going to put AS in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Hurrah! So all the fluorines have 8 electrons and AS has got 10. So therefore we've got 1, 2, 3, 4, 5 electron density regions. Okay, these electron density regions are surrounding the AS central atom, and they're going to repel as far as possible to create the parent geometry of trigonal bipyramid. In this example here, there are 5 bonding and 0 non-bonding, so the shape is also trigonal bipyramid. Okay, now we can actually draw this. Okay, so we're going to put AS in the middle. Okay, your above and below the axial plane are always in the plane, so they are just the straight lines. Okay, I think it's easier personally to do this F to the side, so the T shape like that. Then you have one pointing towards me and one pointing towards you. And the bond angle, there are 2 different bond angles. So this bond angle here between the axial and the equatorial is 90 degrees, and the bond angle between these 2 fluorines is going to be 120 degrees. Hopefully that makes sense. So I'm verbally now going to go through how to justify the shape of this. So AsF5 has 5 electron density regions around the central AS atom. These repel as far as possible, creating the parent geometry of trigonal bipyramid. There are 5 bonding and 0 non-bonding pairs of electrons, and therefore the shape is trigonal bipyramid, and this is what it looks like. Hopefully that makes sense. These are typed out here. Okay. Cool. Trigonal bipyramid. Perfect. So summary of your parent geometries, you've got linear, trigonal planar, tetrahedral, trigonal bipyramid, and octahedral. This one here should also have a bond angle of 120 here. Okay, team. Now these do take a bit of practice. You just have to give it a go, and we're going to do some games on Teams together to help you to learn them. But it's really important to get on top of this. So if you can try and memorize these names, the earlier the better. There is a study guide activity that you can do, but I'd like you to focus on the worksheets that I've put on your OneNote. Okay, team, see you shortly.